Hi guys, welcome back. In this video, we continue our studies of Transition to Advanced Mathematics. It's an introduction to theorem proving class. It's based on this book, A Transition to Advanced Math by Douglas Smith and others. I've got an image of the 8th edition right here, but I'm using the 6th edition. That's the one I was taught out of. We are going to talk about connectives in this video. Or in other words, this video is titled, My Ex Took His Bananas and He Went Home. So connectives are something we're going to define. And by the end of this video, we're going to decide, or we will be able to decide whether it's true that my ex did take his bananas and go home. Okay, so let's define some connectives, or actually before we define the connectives, let's state the goals for this video. We want to first determine whether a proposition is simple or compound. And second, we want to determine whether a given compound proposition is either true or false. The first one's pretty easy. Let's look at whether it's simple or compound. A simple proposition or an atomic proposition is a proposition that does not have propositions as components. We call it atomic because it's like an atom. It can't be broken down any further, or at least, that's how we tended to think of atoms a very long time ago before we thought about all the constituent parts of atoms. Anyway, compound proposition, on the other hand, is a proposition formed using logical connectives. So we're gonna have and statements or statements here with simple propositions. So we're gonna say this is true and this is true, or we might say this is true or this is true. Those are compound propositions, and of course we can say, we can make them even more complex than that. You can say P and Q and R, P and Q or R. I mean, we can go on, but we're going to focus on compound propositions, usually with two parts in this introductory video. Okay, so let's decide, or let's look at some examples. So here are some simple propositions. 4 squared minus 5 is not prime. Now you can do the computation if you want. 4 squared is 16. 16 minus 5 is 11. 11 is not prime is false because 11 is prime, but that's not our concern here. We just want to know, is it simple or is it compound? Well, it's telling me just one thing. It's telling me 11 is not prime. It's wrong, but it's telling me one thing. Since it's only telling me one thing, the sentence is, we call that a simple proposition. Global warming will make Earth uninhabitable by 2025. It's also only telling me one thing, so it's simple. The sky is blue, telling me one thing, so it's simple. Here are some compound propositions. Look out for the and the or in the sentence. Global warming will make Earth uninhabitable by 2025, and Miss Townsend wore a dress today. The sky is blue, or 4 squared minus 5 is not prime. That's an or statement. It's got two propositions as components. That makes it a compound proposition. Or the sky is green, and 4 squared minus 5 is prime. Now the truth or falsity of each of these three compound statements depends on the truth or falsity of the original propositions, the original atomic propositions or simple propositions that comprise the compound proposition. So this first statement is an and statement, and whether or not it's true or false really depends on whether it's true that global warming will make Earth uninhabitable by 2025 and whether it's true that I wore a dress today. The same is true for the second one and the third one. Okay, so now it's your turn. We're just going to try a couple. The University of Tulsa is ranked in the top 100 universities throughout the country by the most recent college ranking guide of the US News and World Report. Is it simple or is it compound? It's got a lot going on there. I mean, it's kind of a long sentence, but it's only really telling us one thing. Since it's only telling us one thing, that TU is ranked in the top 100, according to that particular college ranking guide, we would call that a simple proposition. Miss Townsend's purse is black and Sarah Jean felt bored today. That is a compound proposition. Whether or not it's true or false depends on whether my purse is actually black and whether or not Sarah Jean felt bored today. Okay. Now the truth value of a proposition is just one of those. It's true or false. We call that its truth value. And as I said before, the truth values of compound propositions depend on the truth values of the constituent parts. Okay, now we're going to define 3 logical connectives. The first one is a conjunction of propositions P and Q. The conjunction of P and Q is denoted this way. So you've got this little arrow in between. It looks kind of like a less than sign. but the arrow is pointing up. That is read P and Q. That is the conjunction of P and Q. The conjunction of P and Q is true when both P and Q are true at the same time. If they're true at the same time, the and statement is true. And notice that the arrow points up with a conjunction in that and statement. Now, when you're translating an English sentence that doesn't have an and in it, but it has a but in it, or a while in it, or an although in it, all of those are going to be interpreted as and statements. So let me give you an abstract example, but an example. So let's say I said, XYZ is true, but ABC is true. And say, this is true, but this is true. I'm saying that they're both true. Or I might say, this is true while this is true. So I'm saying this is true while this is true at the same time. That's an and. Or I say, this is true, although this is true. I mean, we are using those words in different ways to imply different things, but logically, those are and statements. The assumption when you're making a statement like that is that both parts, both propositions, both simple propositions that are creating that, coming together to create that compound proposition are true at the same time. And so we're talking about and statements, this and this. The disjunction is the formal name for our or statements. That's denoted by this little arrow pointing down, P or Q. Now, P or Q is true when P is true, or Q is true, or both are true. It's okay if both are true. It's an inclusive or, it's not an exclusive or. Sometimes people will think P or Q just means that P is true or Q is true, but not both. In math, it's actually the opposite of that. It's P is true or Q is true or both are true. This is an inclusive or. And notice that the little arrow in between, that looks like a sort of greater than sign on its side, is pointing down. The negation of P is denoted by this tilde P. It's the proposition not P. Not P is true exactly when P is false. I remember reading that as a student and thinking, not P, what do you mean not P? The long form of that is, it is not the case that P is true. So whenever you see not P, think it is not the case that P is true. All right, so here's our first example. Given the proposition that P is the sky is blue, and the proposition 5 squared is not equal to 25, and that is given the label Q. Given those two propositions, we want to determine the truth value of P and Q, P or Q, the negation of P and the negation of Q. First, we'll just start by determining whether each proposition is true or false. Just look at them one at a time. The sky is blue. It's obviously true. 5 squared is not equal to 25. Well, if you do the calculation, 5 squared is 25, so that's saying 25 is not equal to 25. That's false. Okay. Based on that, we're going to decide whether P and Q is true, P or Q is true, the negation of P and the negation of Q, determining whether all 4 of those are true or false. Okay. And basically what we're going to do is we're going to create a chart, and I'm going to sort of give it away real quick. Those are the answers, but we're going to create that chart in just a minute. I'm going to come back to that, but let's look at all of these one at a time. Let's look at P and Q first. Okay, so P and Q in English is the sky is blue and 5 squared is not equal to 25. In order for a P and Q statement to be true, in order for this conjunction of P and Q to be true, both of them have to be true. Since one of them is false, the P and Q statement is false. Okay, now we have the or statement. P or Q, that would be interpreted in English as the sky is blue or 25, or 5 squared is not equal to 25. Now only one of those has to be true for the or statement to be true. Since the sky is blue, P or Q is true. The negation of P. It is not the case that the sky is blue, or more briefly, the sky is not blue. Since P is true, not P is false. Not Q, is interpreted this way. It is not the case that 5 squared is not equal to 25, or we might say 5 squared equals 25. Since Q was false, not Q is true. Okay, so that is how we handle those. I'd like to show you this on a piece of paper because this is probably what you're going to be doing if you do some problems on your own. Okay, so I'm going to make my little chart. And remember, we were interested in P or Q, that was P and Q, P or Q, the negation of P and the negation of Q. P was the sky is blue, and that's true. Q was that 5 squared is not equal to 25, which is false. So this is my and statement, because that little arrow is pointing up. This is true when both of these are true. Since only one of these is true, this is false. My or statement is true when this is true, or this is true, or both are true. Since I've got one truth there, this is true. The negation of P always has the opposite truth value of P. So if P is true, then the negation of P is false. Same is true for Q. Since Q is false, not Q is true. And remember, if P is that the sky is blue, which is true, not P is that the sky is not blue, which is false. And I think it makes sense that this would be false if that's true. And the same with Q. Let's see, Q was that 5 squared is not equal to 25. We know that that's false. Not Q would be 5 squared equals 25. That's true. So you see how those negations work? I mean, we're just taking the opposite truth value, but I think it's helpful to think through what these statements actually mean, because when I put it in English, it's obvious that if this one is true, that that one is false. And if this one is false, then that one is true. All right, guys. So now we want to go back to that example. My ex took his bananas and he went home. Well, my ex didn't have any bananas here, so he did not take his bananas. So the first part of this compound proposition is that my ex took his bananas. I'm writing this on a piece of paper and we'll look at it in a second. And then because of the English sentence, he went home is that the he in that second part of the sentence is a reference to my ex. So we'll say my ex went home is the second simple proposition. And that one is true. So let's look at the paper. My ex took his bananas, that's false. He didn't have any bananas here. My ex went home, that's true. And it was an and statement. The statement was, my ex took his bananas and he went home. Since one of these is true, he did go home, or excuse me, since one of these is false, he did not have any bananas to take anywhere. Since one of these is false, the and statement is false. Now, if he had taken his bananas and gone home, then the whole thing would be true. Now let's change it up a bit. What if we had an or statement there? My ex took his bananas or he went home. Now remember, with an or statement, either one of these is true or both of them are true. Since one of these is true, this is true. The or statement is true. So then and statement, both of them have to be true for the and statement to be true. For the or statement, one of them has to be true for the whole statement to be true. Okay. So now it's your turn. Let's decide whether each statement is true, false, or neither. Got 5 squared minus the quantity 2 minus 1 equals 4, or Venus is larger than Earth. Pi is irrational, and so am I. It is not the case that e over 3 is less than 1, or square root of 5 is less than the square root of 11, and 5 minus 1 is equal to 4. So if you want, you can pause the video and try each of those. And actually, this time for brevity, I am not going to go through each of these examples, but I will say that the first statement is true. The second statement is neither, because the second part of this and statement, so am I, whether or not I'm irrational is a matter of opinion. The third one is false, and the fourth one is true. Okay, so let's summarize what we've learned. Given propositions P and Q, the conjunction of P and Q is denoted with that little arrow pointing up, and that's an and statement. The disjunction, and that's P and Q, excuse me. That's true when both P and Q are true at the same time. The disjunction is got the little arrow pointing down, that's P or Q. That's true when P is true or Q is true or both are true. And finally, the negation of P represents not P. And it's exactly true, or it's true exactly when P is false. Or you might think of it as it is not the case that P is true, rather than just calling it not P. Okay, that's it for now. Next time, we're going to talk about propositional forms, well-formed propositional forms, and we'll create truth tables for P and Q, P or Q, and not P.